I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We have 17,000 absolutely free videos for our students with 400,000 subscribers. A learning platform for active participants. In this playlist, we are sharing many brilliant questions from IBHL past test papers. And we have an integrated approach to learn different strategies as we move along. Many of my solutions, which you must have seen by now, are very different, or maybe slightly different sometimes, from the normal standard solutions. Reason being is that we try to give you the best possible, the one which makes sense, shorter, and easy to understand. So, with that, let's begin with the solution of this question, which says write the expansion of 3 minus x to the power of 5. Hence, find the exact value of 2.9 to the power of 5. Makes sense, a typical of IBHL test question. So in the first part, once you expand 3 minus x to the power of 5, in the second part, 2.9 could be written as 3 minus, you can see, 0.1 to the power of 5. So it's a direct application of the expansion. Perfect. How do we do that? Binomial expansion. Simple as that. So, if a plus b to the power of n we're looking at, then we write nc0 a to the power of n plus nc1 a to the power of n minus 1 and b and plus nc2. Basically, the powers of a decreases from n to 0 and that of b increases. In the same order, the sum always will remain the same, right? Simple as that. So, like this, you just go on. And the last term will be b to the power of n. Ncn, which will be 1, b to the power of n. Now, in this case, since we have 5 there and minus x, let's rewrite the expansion. Can you tell me how many terms will be there? Well, if 5 is the power, let's see how many terms will be there. Yes, I think you're right. There will be 6 terms. We start with NC0, right? So 0 to 5 makes 6 terms. Great. So looking into this, n is 5 for us. So let me write 5 here. Okay, so 5 terms, 5C0. A for us is 3, so I'll write 3 to the power of 5 plus 5C1, 3 to the power of 1 less than 5, which is 4, and we get minus x. So alternately, the terms are negative and positive. Starting with the positive number, and then the next term, nc2, 3q minus x squared. So that becomes positive, plus nc3, 3 to the power of 2, 5 minus 3, and minus x squared becomes cube now. So 2 plus 3 is 5. And let's write down the others, plus nc4, 3 to the power of 1, and minus x to the power of 4. In the last term here, the sixth term, I am writing n, but it should be 5, right? Okay. Let me just convert all of them to, let me write 5 here, overwrite. Okay, that's clear. 5 for all, correct. So 5C5. 3 to the power of 0, so I'm not writing it now, minus x to the power of 5. Correct. Use calculator to find these binomial coefficients. Use Pascal's triangles, rewrite it down, but calculator definitely is far better. So we get what? We get 3 to the power of 5, which is 243, right? So we get 243 here. Plus, now since we have minus x, it becomes negative. So alternately, negative and positive terms, when you multiply, you get 405x, right? Minus 405x. Next term will be positive. And use your calculator, you get 270x squared. Then negative, and negative will be 90x cubed. Then we have positive 15x to the power of 4, and then negative x to the power of 5. Great. So we have this expansion right before us, right? 3 minus x to the power of 5. And that's your answer for part A, right? Now it is time to apply this equation and get the answer for 2.9, where instead of x we have 0.1. So I'd like you to pause the video, put x equals to 0.1 in this expression, and find the value of 2.9 to the power of 5. Correct? You can very clearly see that 3 to the power of 5 is 243. It has to be lesser, right? And so this term itself will reduce it by 40.5. And then we are slightly increasing and decreasing. But in the first two, three terms, if you consider these three terms, you'll get fairly accurate value for 2.9 to the power of 5. Accurate to almost three decimal places, right? You can say three significant figures to be more precise, right? So, okay, three decimal places for sure. Okay. So, because these terms are very, very negligible, right? Minus x to the power of 5 and x is 0.1. So 0.00001 is a very small value to deduct. Makes sense. So let's do the answer for this and calculate on a fresh page. So 2.9 to the power of 5, we are going to write as 3 minus x, which is 0.1 to the power of 5. And we are going to use the formula which we just got. Okay, so better to write the formula first, right? So, okay, so what we got was 3 minus x to the power of 5. We got equal to 243 minus, alternating minus and positive negative terms, 405x plus 270x cubed square, right? Sorry, 270 x squared minus 90x cubed plus 15x to the power of 4 and minus x to the power of 5. So we are going to substitute for x 0.1, correct? So 243, which is 3 cubed, minus 405 times 0.1, right? Then we have 270 plus 0.1 square, right? Minus 90 0.1 cube plus 15 0.1 to the power of 4. You see that, right? So these are very small terms, right? You could neglect them, do first 3 or 4. You are going to get a fairly good value. And then you have 0.1 to the power of 5 to be reduced. That is it. Now use a calculator, calculate all these values. Once you do that, what do you get? Well, you get 205.11149. So that's the value which you land up with, and that is 2.5 to the power of 5 when you take all the values. So I hope you understood the process. First expand and then substitute the value of x, get your result. Now, if you want approximate values, you can also use just first three terms and see for yourself what do you get, right? You get fairly accurate result for at least two decimal places, right? So this is something which you should experiment as many times in these questions. You may be neglecting other terms, just using three of them. Well, so with that, we come to an end of this video. In case you really want to understand the topic in details, you can always send an email to me, which is on globalmathinstitute@gmail.com, and learn directly. So like many others, benefit and get A star. Great. Thanks for your valuable time and all the best.